Good morning, grasshoppers. I want to chat with you about truth functionalism in chapter 6. Um, First of all, let me share with you that all your assignments this week are due the 17th. For some reason, Moodle did not uh, auto adjust the assignments, and so it was brought to my attention by several students this morning, so I manually went in and corrected it. We're all good. Truth functions are not hard, but they are mechanical. And so you just need to be very methodical in dealing with the mechanics of truth function. They're really pretty simple, but they're a good method for testing validity. That's all that truth functions do, are testing for validity in an argument. So I want to just run over a little bit on 342 in your textbook. In my textbook, I have the hardback edition. Definitions of the logical operators. That's where you'll want to go. So the negation is pretty simple. If P is true, not P is false. The conjunction, when we get into the conjunction, the disjunction, and the conditional and biconditional, this is where you have to sort of memorize the rules for these. That's just what I'm going to try to give you. So the conditional is only true when both variables are true. P and Q have to be true. All other instances of the conditional are false. In the vel, or the wedge, or the disjunction, we used to call it the vel when I was an undergrad. the vel is only false when both variables are false. All other instances, it's true. So the conjunction, it has to be true. And in the disjunction, it's only false when both are false. You want to, look at these and you want to memorize them, if you will. The conditional, all logical arguments are conditional statements. If P, any number of variables, if P is true and the conclusion is true, the argument's valid. If P is true and the conclusion is false, then the argument is invalid, and only under that circumstance. So if you look on page 345, it's showing you, 344, it's showing you that if P is true and Q is false, then the connector is false. The conditional is false. All other instances of it are true. The biconditional on page 345 is showing you that it's true if and only if both variables are true or both variables are false. So this sounds a little confusing, but if you just read these over, if you look at the diagrams, it'll come very clear to you. And these are the rules that you want to operate with. I think they're simpler if you just memorize the rules than if you have to constantly go back and look and all of that. So, given those rules, let us jump ahead to 354 and 355 in your textbook. Truth tables for propositions. This is 6.3. And the way you're going to want to look at this as we see the argument on page 355, A or not B, if that, then B. Now, there are only two variables in this argument. So the way you're going to delineate that is if you go down, you'll look at the variables that are shown, and you always start from right to left. So the first variable would be B, and that will be true, false, because there are only two variables. So it's true, false, true, false. The next variable is A, and that is true, true, false, false. Why do it that way? Because true, false for B and true, true, false for A gives you every instance of true, false for those two variables. That's why you do that. Now, you'll notice you've also got in the argument, you've got a negation. You've got not B. So what you're going to do as you're going through, you're going to solve for the tilde or the negation sign for B. So that comes out false, true, which is just the opposite of B. Once you have that, then you're going to solve for the wedge using the variables for A and not B. That will be the solution for that wedge or that disjunction. And you can see the variables here. For A is true, true, false, false. And if true, then if true or false is true. And you can work your way right down the lines. When we turn the page now onto page 356, now you're solving for the disjunction in the parentheses. You're using that as your variable for if P then Q. So it would be the P side, the disjunction, and the variables for B, which are over on your left. So now you're looking at if true, then true, that's true. You're solving for the conditional. If true, then false, of course, by the rule, is false. And write down the lines. So what's important for us at this point is if you have an instance in any one of the lines on a truth function that is false, the argument is invalid. And the way you would stipulate that in this particular example is it would be invalid on line 2 and line 4. You would just stipulate that invalid line 2, line 4. Now, to have more fun, the next one has 3 variables. So we have E, D, and C, or C, D, and E. Once again, you always start on the right and move to the left. So E is true, false, true, false, true, false. And you'll notice that you have 3 variables. So for D, you'll go true, true, false, false. And for C, you'll go 4 trues and 4 falses. And then you have to fill in on every line. That's why they have this delineated. So you move over on page 357, and what we're going to solve for first is always within the parentheses or the brackets, always within those elements in an argument. So in this particular case, we're solving for the conjunction. Remember, the conjunction is true only if both are true. Okay? So we can, first of all, we have to do the negation sign for the D. So we just mechanically go through and negate the variables for the truth functions for D. Then we're going to solve for the connector, the conjunction, using the variables for C and not D. And that gives us, of course, those variables, the truth functions under the conjunction for those particular true falses. Once you have that done, now you're going to use the resolution for the conjunction, and you're going to use that to solve the conditional. And you'll use the conjunction, truth functions, and the truth values for E. And that gives you the lines, all 8 of them. And you'll notice that the argument is invalid on line 4 in your textbook. And the reason for that is because the conjunction is true and the E is false. So the conditional is, if true, then false is always false. All you need is one line in the variables, or the truth functions. Only one line is false and the argument is invalid. Now, they go and give you several more examples here, and they're all pretty much the same. Okay, so like I said, the truth functions are really easy. Where they become difficult is in the mechanics. So you have to follow the mechanics very carefully. And we've done translations, so we can translate arguments into symbolism, and then we can do a truth function on them. That's an easy way. You're not guessing then, you're testing the validity of that argument. Remember, the validity may or may have nothing to do with truth. So that is a sound position if it's both true and valid. Okay. Where it gets to be really fun, where they're showing you, your textbook mentioned an easier way to do these truth functions. I'm going to show you that next week. I don't want to get you confused. It is an easier, simpler method, but you really have to have this part just down cold turkey. You have to know this to really be able to do the indirect method. So, this is, like I said, pretty straightforward, and you just need to focus. You need to memorize those rules for the connectors, and you'll be absolutely fine. So, I look forward to seeing your work this week, and I think you're going to. So far, you're doing very, very well, and I think I mentioned that if you do your work in Word, and I put it up in terms of how to find the symbols and things that you can use. Okay, I want you to have a good week. I think you're doing very, very well. And like I said, let me reiterate, this stuff is not hard. It's just mechanics. So you have to master the mechanics. All right, sports fans, you have a good week, and we'll talk to you soon.